Hello and welcome to Chaos and Caffeine podcast number 17. This time I checked. In any case, we are today going to try the other Guatemalan coffee. This is called Caffeine Guatemalan coffee with Cardamon. So we're going to talk about that in just a minute. Just got back from a long trip to North Dakota. I highly don't recommend driving the 14 or 15 hours there from Chicago. We had a good car full of techs and everybody else, and we got up and did a overhaul on a bearing where they had an issue with lubrication. So that was a lot of fun. Rebuilt the bearing and didn't leak. We're still watching it to make sure that the oil turns clear. But primarily, the problem was somewhere along the way, somebody accepted, we'll just say, an LLM telling them that they could use a hydraulic fluid versus a turbine fluid for lubrication and save money. So, subject matter experts, folks. I mean, heck, I just saw an article this morning and I had to read it because let's just say it's nothing new. We've been noticing it. Wharton says young job seekers need to focus on something other than skills. Well, we've noticed that in some engineering areas as well, where we have seen some people get out of, say, electrical engineering, and they don't have any real-world applicable skills. And I had an argument with a professor at a university about that when I was in Denver the last time. I'll be in Denver again here shortly to talk about what we're going to talk about today. And had an argument with him about the fact that he said, they don't need to teach electrical engineers how to use a multimeter, how to use other tools, how to solder, how to, actually physically build a circuit. They need to teach them simulation and how to read a book. So what can you do with, I don't know. I guess that's the new thing. Kind of like, some of these, consultants where they get right out of college and they run around, and the number one way to get a business to save money is chop heads, get rid of people. I mean, sure, you save money in the short run, you destroy a lot of knowledge and everything else. So it look good, it looks like an immediate savings, and stock prices go up a little bit if you're publicly traded, but in the long run, good luck. We've watched that happen in many companies, and including some that I was involved in, just horrible deals. So, as always, when people think they know what they know, and just because there's a lot of money involved and brand names and stuff like that, doesn't mean it's right. We'll talk about that as well on our topic today. So in any case, cardamom. So, it's a spice, of course, from India. It used to be worth more than its weight in gold. Some things, citrusy brightness, minty coolness, gentle spice. That's the description. I looked it up a little bit. A couple of different brewing methods, including similar to the Turkish coffee we talked about before, or grinding with coffee beans, which is what I have here with this, or infusing or garnishing. So it is supposed to be gentler on the stomach, reduce caffeine jitters. Oh, come on. What's the point? Rich in antioxidants and nutrients, and it has some traditional medicinal uses. I'm having to read off of notes today. That'll include during my discussion just to remember some of the stuff. So it'll go long again, but we're going to talk a little bit about the history of the electrical system. Popular regions. Okay, so in any case, this is Guatemalan. So I haven't tried it yet. It really, really smells good. Oh, and by the way, the cup I'm using today is a lot larger than one I normally use. And by the way, for those who have watched the podcast from Croatia, I now have one of those cups for the Croatian coffee or European coffee. In any case, so it definitely has an aroma. I brewed this in a pot. It's ground. It does specify that it's going to be aromatic, so let's try it. Yeah, I was supposed to drink it within a half an hour of brewing it, so I've got a big pot of, I made 10 cups. Definitely not bitter, definitely smooth. We'll see how the caffeine kicks in. Another thing you'll note is the coffee cup says strike tape and weather guard. So the weather guard podcast, uptime podcast for wind, I did that, let's see, the last one I did, because I've done several with them. They have on YouTube alone, they have 1.4 million subscribers. My discussion on electrical signature analysis for wind turbines for the entire system, including condition-based maintenance, lifetime extension. We had a good, solid discussion. That one's had 25,000 views. So not too shabby. Way more than my 2 views. It's available in Apple, Spotify, and Overcast. Haven't heard of Overcast before. And a few other areas. Alan Hall and the team does a great job in interviewing. I will put a link to the one that says Motordocs Electrical Signature Turbine Diagnosis. I'll put a link to that. It is much shorter than this one will be. It's about 25 minutes. As we've run into with some of these podcast tools that people use, for whatever reason, they don't get along with our system, so I keep dropping out. But neither here nor there. It's part of the reason I don't do these live right now. We will do a live one soon with an interview. So let's go ahead and get into some of the stuff we're going to talk about today. And that is basically some of the things that have happened over the years. So one of the discussions we've had as part of the grid code discussion, because I'm working on the next part. I've made some changes which are accepted, saying that, hey, there's a history to this. Now, luckily, I've been part of that history through my career. So my original employer, when I got out of the Navy, gave me the okay to attend some things in Washington, D.C. with IEEE, because we were involved in all kinds of Department of Energy stuff and everything else. So the Chicago section, we had the Region 4 Energy rep. He said, hey, I need you to be Region 4 Energy rep for a couple of years. So that meant that I represented 10 Midwestern states from IEEE for the utility power generation. So now I'm the Seagray A1, meaning power generation, the generators portion for Seagray USNC. So that was also appointed, heavily involved in IEEE, but 128 countries of utilities. So all the utilities, like when we do our Grid of the Future thing coming up, that'll be part of that. The reason I was in Croatia primarily was to do some stuff on wind turbine and electrical signature analysis. We have noted that, things, let's just say, those are my style of conferences where I can have discussions. They're technology based. They're not salesy, except for all the people that buy booths get a couple of minutes on stage, right? That's the usual thing. I think I saw one company get up and say, "Oh yeah, look, they accepted us. We're presenting this for the first time ever at one of these conferences, and it was a big deal." And no, it was the sales presentation. You can always tell by the person doing it. But I digress. So getting into power generation back then, this was 1994 and 95, leading into the deregulation in 1996. So going back even further, as we go through our discussion, the grid has not changed really since Nikola Tesla first patented most of it in the late 1800s. Now, I did see a Power Engineering Society magazine article, historian article, and of course, going back into history, Nikola Tesla, when Thomas Edison went over to GE, or GE was created with him, they did everything possible to bury Tesla's name. So they worked really hard at it. They did not like each other. So it was, heck, Tesla walked away from a Nobel Peace Prize over it. So in any case, back and forth over the years. Recently ran into a field technician I knew, lineman, that was working on upgrading some lines. He said the power lines hadn't been upgraded. So we're, since they were originally installed. And I said, when was that? He says, we're not quite sure because all the drawings are gone. He says, but basically the tower itself says Carnegie Steel on it. And it wasn't at the end of Carnegie Steel. So Carnegie Steel became U.S. Steel in 1926 or 1936. 1926. So most of the infrastructure we have in the U.S., the original infrastructure, can be more than 100 years old. And of course, technology has changed a lot since then, not just on the user side, but on the power generation side. So skip forward to 1994. Now, skip forward to 1994. The big discussion was about deregulation, but the problem we had was storage. Energy storage at the time was primarily pumping systems. You would pump up a reservoir with a machine that then would turn into a generator as you drained the reservoir back into a river. That meant that you had the same limitations you had on hydro. So they weren't everywhere, right? So in any case, that is good. A little spicy, kind of like when I put cinnamon in my coffee, which we'll probably do next week. In any case, so all the thing we had said was, everything was primarily nuclear, coal with nuclear. How are we going to deal with deregulation? Because all of a sudden, power generation wasn't going to be able to manage spinning reserves. Relays within the grid were going to need to be changed, and all the safeties that were put in after a big blackout that impacted New York City in the 1970s and killed people, that needs to be dealt with too. And of course, the politicians became engineers, as they always do, and decided they knew better than everybody, and everything moved forward. So stuff got deregulated. And the next thing, the unexpected consequences came about, because now the market's involved, and the market said, you know what? Not only can't we have spinning reserves, but these coal-fired freaking power plants are expensive. Now, nuclear power stayed regulated, so not as worried about that. It's just going to be expensive. So that's going to be our base load. The next part, our base loads, we can start varying those a little bit. So they go ahead and discover that they can use what normally were peaking plants, like plants that you could push a button and come up and run and would take care of things. They can be started faster. So then, of course, the boom of natural gas came about. So all these natural gas power generation plants started popping up because less expensive, less costly to run. and you could start and stop them. So now the original power generation, which you might start a coal-fired power plant a few times a year, we're now starting almost every day. Well, it took almost a day, but far, far more frequently. Well, when we design electric machines of that size, well, of any size, but in particular power generation, you specify a minimum number of starts across the life of the machine. So the 40-year life or the 20-year life of that machine has to be able to start so many times. So the designers, the material folks, everybody, that's what they designed around. All of a sudden, that's not what was occurring. So they were starting more often, and maintenance issues started coming about. So we started running into availability issues. So this was the first time round. So we skip forward again, and more recently, because of, well, you take the outage of 2003, right? August of 2003, where we lost the Northeast. That was again based upon changes that had been made in deregulation, because the grid, everything that goes on within the grid, even though we have regions, right? There's an East Coast, a West Coast, and then ERCOT, which is Texas, grids. Each state runs what goes through as far as power lines and everything else. So it's basically state-run grid with a bulk grid on top. The bulk grid is part of that. So you have to deal with the regulations and everything else within each state. Then as we started into electronics and communications, which we were discussing that in the 1990s, in the 2000s, it really started coming about because they would put signals in the line itself at higher frequencies other than 60 hertz. Well, now with all the electronics in the system, there's noise induced as well. So we skip forward to now, and the discussion is now that the gas turbines are having problems because alternative energy can start and stop instantaneously, meaning that the natural gas plants are starting to cycle, and in cases where they can use the less expensive systems like wind and solar and battery storage, what we now call IBR, or the collections of different diverse distributed energy sources into virtual power plants, all of that is having a direct impact on the cycling of not just coal and nuclear, but also now natural gas. So all of a sudden, these plants that were, say for instance, a natural gas plant, I saw one where it was kind of a headbutt because they were saying we want it to be able to start 500 times a year for so many years. Well, you can do it. It's going to be expensive as hell. So that kind of thing. So that's where we are right now, is that things are starting and stopping far more often. A lot of coal plants have been retired, not because of politics. I keep hearing that. It's because of politics. No, it's because they're expensive to run. I don't care what you see on TV. There are actual economic facts. So coal-fired power plant with all the environmental protections we have put in there, plus the sheer size of it and the cost of the fuel, it's not cheap. Just like with a nuclear plant, which is the most expensive. It's the fuel is cheap, so running it is relatively cheap, until you throw the bureaucracy on top of it. But you need the bureaucracy there, right? It's a safety issue and everything else, because unlike coal, you get a little bit of coal around. If there is an ignition, it's relatively limited. If you have a Chernobyl event or a 3 Mile Island event, that can affect a lot of people. Matter of fact, if you watch the movie Chernobyl, I think HBO did a series on it, you'll see that they were worried because the effects of the fallout and the problems with the plant would have affected all of Western Europe, not just, and possibly as far as the U.S., not just that immediate area. So it was, these are things we have to consider. So now we're looking at a grid in which we are The latest numbers came out. Everybody's estimating still because the data center folks do not want anybody to know how many data centers are out there and how much energy they're using, as we're watching our energy costs go up in the regions that have a lot of data centers, right? We're at 12%. So 12% of the total electrical energy produced in the United States hits data centers, which is a lot faster than what I thought it was supposed to be. There's other things going on from a financial and governmental perspective. I'm seeing what people are saying, but it's outside the scope of what we're talking about. So, yes, I'm as concerned as everybody else is. There's a whole lot of promises, not a lot of return, a lot of money being thrown around. And yeah, we lived through it. I've lived through that whole thing now twice. The dot-com bubble and the housing bubble, and this is supposed to be much more massive. So just things to keep in, and you couple that with the water issues and the power issues. People are getting creative, but what do we have in the end? So let's take a look at the history a little bit. So 1996, or pre-1996, we had, units that took up to 12 hours to start. For coal, it took a day or days for nuclear to come up to speed, so you ran them, and then you had what are called spinning reserves. So you would have base-loaded system, which were maxed out. You wanted to keep them at, unless they were derated for specific issues, but you wanted to keep them pretty much close to full load, and you didn't want to do a lot of cold startups on them, because every time you start and stop, it fatigues or wears out components in the system. So as we hit deregulation, things were expensive. I mean, the fuel was expensive. I mean, Nikola Tesla, when he first came up with the ideas, he actually saw hydro, wind, and solar as the primary means of providing electricity. Also saw certain other things, but that's neither here nor there. I mean, his stuff was grounded in science, as we're finding these days, but not any of these scamming, pulling energy out of the air from the universe things that we've seen, the perpetual motion machines. But that's neither here nor there. He saw that, but of course, at the time, his funding was coming from investors, and J.P. Morgan, who was his primary investor, he owned coal plants. He shipped coal. He had a vertical organization, and he made his money off of coal and other and things along those lines, right? So, all the big robber barons of that time, they were coal and steel and stuff like that, the stuff that you use to build infrastructure. So they owned everything to get that stuff around, from railroads to you name it. So that became our primary fuel. So now we come back and we're starting to change it over. So from the 1990s to about 2000, combined cycle gas turbines, and a few other things. In the UK, there was a point in the 1990s that called it the dash for gas. And all of it had to do with the fact that they could start up faster, gas was less expensive, and so we saw the cycling of the other plants. So post 2000, matter of fact, the year seems to be about 2003 when your utility scale wind started coming in, as well as we started seeing more solar coming into the market. So all of a sudden, all of the standard large rotating power generation, that had to start and stop more often. Now, we definitely needed that, and still do, because of the inertia. So anytime there's a change in frequency, something shorts down the line, any type of event that occurs, you have to absorb that. We see that in large turbines as being able to handle those subsynchronous frequencies, but we're seeing those fatigue the smaller generators such as wind turbines. Now we add in a bunch of other things now. So as we inundated, this year while I was overseas, they announced for the first time, this would have been about, a month ago, so in October, that for the first time in history, alternative energy exceeded the production of coal in electrical output. Now, there were certain things that have occurred over time, and this is some of what we're fighting because bias is in all of this. So, part of my thing is, I speak a lot on wind and things like that. I'm very involved in it, so I have a bias. I know I have a bias. That's what's important, is understanding that I have that bias. So I like having that bias because then I try to see things from a different perspective. And I watch people jump on something and a statement will say, this was absolutely not caused by, alternative energy. And then I'll have the other guys come back and say, look, the sentence says it was caused by alternative energy, because their bias has rewritten the words that are in front of them. We can see things differently based upon our bias. So I've been fighting that in grid code committees and grid-related stuff globally. As well, I'd like to say there's a lot of other people as well. There aren't, unfortunately, including those that should be. But that's neither here nor there. That's their choices. I'm going to do my choice. We do not make a huge amount from that industry as a business. It's a smaller portion of our business. But I believe that we need all forms of energy to be available. So I think I've gotten rid of all my notes now. So basically, right now where we are as well is because of that bias, they're starting to see these high frequency noises, which we've been investigating now for some time, has only been a topic within the last year or two within the engineering industry, including the grid industry. And we had been investigating it for longer than that, looking at bearing-related issues in wind and commercial and industrial applications. Well, we also noticed the high-frequency noise sitting on the line, so we started investigating what's at the point of common coupling with wind, for instance, including the high-frequency range. And we are seeing some, but we're not seeing the levels that they talk about existing in the bulk grid, but we are seeing it from data centers. So they equated the increase. Correlation is not causation, folks. So they basically said the increase in this high frequency noise was because of the increase in IBR, when at the same time everybody's carefully ignoring the end user. This becomes important because there's a push on eliminating IBR. And within the utility, within the grid, okay, so we're talking about a grid that's been around for a heck of a lot longer. It was never designed for modern loads. We are seeing now all of this junk coming online, and it's affecting, if I have a data center here and, I have a business 3 miles down the road, that data center here is going to be affecting that system electrically. And as we're electrifying everything and we're adding in all these other charging stations and nobody's filtering anything because it costs money, all of that stuff gets tossed back, gets moved up. And then, of course, how do we deal with it? So some of the corrective methods used to maintain voltage. So let's talk about, I did a talk on this already, but I'm just going to brush across it. So the Iberian Peninsula, or Spanish shutdown, or Spanish power loss in March. Why is that so important? We're all talking about it because, not just because it was a big deal and it was in everybody's face, but because it was seen as a forewarning of what could happen when you don't do certain things. So the challenge we run into now is how do we react to stuff? Because it went exactly the way it would have expected to go based upon what was going on. So I need to say on the grid. So all my loads are measured in amps or current. Okay, the flow of electricity. The pressure, like in a compressed air bottle, if I need 100 psi of air all the time, I'm going to be pushing air into that bottle, so I keep 100 psi, right? Well, voltage is electrical pressure, kind of like that psi in a air bottle. So say we need to keep it, well, for Spain, they needed to keep the nominal as 400 volts as their electrical pressure or voltage. So with a trip out at 435. So at some point they had an event and it caused basically some large load shut down. It caused the voltage to increase. So they countered that and they brought the voltage back in line. It oscillated a little bit because some event occurred. We have a good idea what it is, but nobody wants to talk about it, so I'll steer clear of it as well. Data center. But in any case, we're talking about a very large load comes offline, so voltage floats up. And they were having this issue, and it'd been going on for more than that day. It'd been going on for a little while, except this time, a transformer in the southern portion of Spain, the primary fails. And as soon as the primary failed, they lost somewhere around 800 megawatts worth of solar and gas-fired generation. They had everything tied into this one transformer. So all of a sudden, the voltage floats up to between 415 and 420. That's kilovolts. So 415 and 420,000 volts. So they started countering things to try to get it under control, and the voltage just kept rising. And then all of a sudden, they hit a point early, well before the trip line of 435 kV, where France stripped offline, power plant stripped offline, and then the voltage floated up above 435, so everything went into protection mode and shut everything down. So basically, that was it. So we need to maintain voltage control. Well, 40% of the power that was being generated at that time was solar, and there were double digits in wind, and none of them were set for voltage control, meaning that they could have been used to correct that voltage issue. We do that all the time. There's going to be a paper at the grid conference where they talk about, oh yeah, we got this AI to do this. It's like, wait a minute. Where'd you get that information? I looked down. It's like a paper from 2007 is what they were basing their solution on. Well, in 2010 and 11, we had developed something called wind ride-through, which also involved voltage control, frequency control, and a few other things. So after 2011, any new turbines that were going up had the ability to do voltage control. You don't need an AI for that. I mean, sure, you can have some control stuff, but the correction was for something that's already been corrected. So I read the paper already. I'll see if I have questions when I get there. Or I just won't say a word and just let it do its own thing. So now the thing that we're challenged with, in addition to the fact that we're not going to have power, because the decision's basically been made that everybody gets to absorb the cost of the new mega centers that are going up, primarily in places like Virginia and other states and areas where there's power there and it's cheap. So it isn't afterwards. We saw that in upstate New York, where cryptocurrency sites went in, and that 12%, by the way, does not include those. Cryptocurrency sites went in, and the people there, because they were getting hydro down from Quebec, were enjoying 6-7 cents a kilowatt hour. All of a sudden, it jumps to 25 to 29 cents per kilowatt hour, because the guys came in and they're taking up all the lower cost energy, and then the energy costs go up overall. Well, same thing's happening elsewhere. So those are the challenges that are being faced. How do we drive those costs down for the citizen, this general citizen? Like when I go home, I'm in the area that's being hit really, really hard with we'll call it the JPM, or the region, the operator region, and then Northeast. That also impacts through Chicago and Joliet and Central Illinois a little bit. Then MISO is the center area. We saw huge cost increases this summer. And in some areas directly in the East Coast, they saw as high as 25%. Well, that's now being projected going up another 50% within the next few years as all these systems are being brought into play. So, on that really great note, what does that mean? Well, that means we need to get power generation moving. And the stuff that we hear, oh yeah, things are being approved within weeks or months, that's the loads. That's not the new power generation. New power generation takes years for approvals. So what's happening is a lot of the data centers are having to self-correct by building their own behind the meter, meaning the stuff that's not regulated as hard. So they're putting in their own power plants, or they're calling them cogen units, but it's effectively a power plant. They can't feed back on the grid because they're not a utility, so they have to partner with the utility. It gets really, really complex from there. So now we're sitting here with an ancient grid with newer systems going on, stuff we've never dealt with before, and are unclear on how to deal with it yet. That we're now challenged with. There's some younger folks coming in, but apparently they're not being taught skills. Sorry, we got a lot of really good folks coming into the industry, of course, but we are dealing with a lot of issues, and we've got a lot of old guard in there as well, with specific bias. And we've got the younger guns with specific bias, and I'm not clear if either side is correct at all. So far we're seem to be surviving. It's probably not going to be doom and gloom. I think the AI industry is more or less like that. If you haven't heard of it, Neo robot thingy. Which is actually a human being remotely operating it from somewhere else. And it's not an AI. It's not a real autonomous robot, apparently. But that's neither here nor there. I kind of see that entire AI industry as that thing. Just like I do with the condition-based maintenance industry now in my part of the industry. A lot of these places are selling, I'll just call it vaporware. But neither here nor there. In the end, it's all going to shake out. I'm not sure if it's going to happen sooner or later. But from what we're seeing, because the economy is not as good as what's being said, mass layoffs being blamed on AI when that's not why they're being laid off. It should be interesting. We're preparing for it. We'll see what happens. With that cheery note, I'm going to leave you the link to the technical discussion on electrical signature turbine diagnosis from Uptime, from WeatherGuard Lighting Tech's Uptime Spotlight. We'll have that in as a link. You should be seeing it about now. On a positive note, like I said, we're off to the Grid of the Future conference. We're one of the primary sponsors there. The focus we have is on reliability of power generation systems. I'm going to be focused on some wind-related stuff because that's been our area of research. We've been slowly shifting to other areas, but wind allowed us to do a deep dive into industrial applications. we've been applying those pretty handily. I'm sure you've seen a lot of articles. There is an article coming out on reliamag.com or Reliable Magazine. That one will be kind of the history of power generation, what's gone on over time, and why things are cycling so much. Gave it to him last week, so I was hoping to put it in as a link, but watch for it. I'll mention it next week. We should be coming back, assuming we get a flight back, and assuming we get a flight out there in the first place. Supposedly our flight is fine. Actually, I should be checking in about now, the 24-hour ahead check-in, and then we'll go from there. So in any case, have a great weekend, and hopefully this was nicely confusing for you. This coffee was fantastic. Thank you, by the way. And we'll see you next week.